Good morning, students. Today we discuss a very important concept of this chapter, that is trigonometric identities. As you know that what are identities? Identities are used to make our calculation easy, right? As you discussed in earlier classes, that identities are true for all variable in it, right? So here we discuss three identities and how we verify that these identities are true. So for this we consider a right angle triangle ABC where right angle at B. So by using Pythagoras theorem we can write hypotenuse square is equal to base square plus in triangle ABC. Understand? Now divide AC square each term. We can divide same term, same value by each term, AC square, AC square, AC square, right? So what is AC square, AC square? 1 is equal to what is AB upon AC? AB means adjacent upon AC, hypo. Adjacent upon hypo is what? Adjacent upon hypo, cos theta. So for this angle A, we use here cos square A plus BC, opposite upon hypo, BC upon AC. Opposite upon hypo is what? Sin theta, sin square A. Here we get our first identity. Sin square A plus cos square A is equal to 1. Or in general we can say that sin square theta plus cos square theta is equal to 1. Generally we used this identity in form of this, or we can write this identity cos square A is equal to 1 minus sin square, or sin square A is equal to 1 minus cos square A. Understand? By transferring these the values, if we can know cos square A, 1 minus sin square A. If 1 minus cos square A, we can write sin square A. Understand? Now, if we divide here BC square both sides, BC square, each term divided by BC square, BC square, BC square, BC square. What will we get here? BC square, BC square 1 plus what is AB upon BC? AB upon BC, AB upon BC, adjacent upon opposite. What is opposite upon adjacent? Tan theta. Here adjacent upon opposite, reciprocal of tan theta, that is cot theta. So cot square A. What is AC upon BC? AC upon B, BC upon AC, opposite upon hypo is what? Sin theta. Opposite upon hypo. Here it is hypo upon opposite. Hypo upon opposite. It means cosec square. That is our second identity. 1 plus cot square theta is equal to cosec square. Or we can write cosec square A minus cot square A is equal to 1 in terms of 1. In terms of 1, we can write this identity cosec square A minus cot square A is equal to 1. Now the last one, we divide what? AB square. First we divide AC square, then we divide BC square both sides. Now here we divide AB square both sides. Each term divided by AB square. Here we get 1. AB square upon AB square 1. Look at here. What is AC upon AB? AC upon AB. What is AB upon AC? Adjacent upon hypo is what? Adjacent upon is hypo is what? Cos. Yes. So what is reciprocal of cos theta? Sec theta. So here we have sec square A. Now what is BC upon AB here? AB. AB upon BC. AB upon BC is what? Adjacent upon opposite is what? BC opposite upon adjacent. Opposite upon adjacent, that is tan square theta. BC upon AC. So plus tan square A. This is our third identity. Or in terms of 1 we can write sec square minus tan square. Sec square A minus tan square A is equal to 1 in terms of 1. So by using Pythagoras theorem we can form a trigonometric identities Sin square theta plus cos square theta is equal to 1. Cosec minus cot square is equal to 1. And sec square minus tan square is equal to 1. So this is all about the trigonometric identities, and in the next video we will see that how we use these identities to solve another trigonometric identities, and we can use these trigonometric identities to express the trigonometric ratio in another form. Okay, thanks.